we're going to find the inverse of this function right here, f of x. It's an exponential function. I need to find the inverse of it. And the nice thing about inverses is no matter what the equation is, your method is basically the same. It's these 4 steps every time. So I'm going to follow those 4 steps here. And the very first one is to rewrite the equation, except use y in place of f of x. And it's not like that's super important, but it does make the algebra easier to keep track of. So there's my step 1. I just rewrote y. And now I'm going to switch all the x's and y's. So now it becomes x equals 7 to the negative 2y plus 5 minus 1. Okay? And now comes the third step. This is usually the only hard part right here. Step number 3. That's the tricky one. Solve for y. In other words, get y by itself. So what I've talked about in class, which you'll remember, is always work from the outside in. It's like unwrapping something. So the first thing I'm going to do is I'm going to add 1. I'm going to peel that 1 off of there, and I'm just going to turn this side on the left into x plus 1 equals 7 to the negative 2y plus 5. Okay, great. Now I have an isolated exponential. Well, that's really nice. Now we can turn it into not an exponential by applying a logarithm to both sides. So what that's going to look like is this. I'm going to take the log of the left side, like that, and I'm going to take the log of the right side, like that. And to make this easier, let me clean up that plus 1 business. To make this easier, I'm going to choose a base for that logarithm that will cancel out the base of the exponential. If you look at that exponential, see that 7 right there? I'm going to choose log base 7. So let's watch what happens as I expand this out. On the left, nothing special. It's just log base 7 of x plus 1. On the right, some interesting stuff happens. Number 1, if you notice this exponent right here, according to the power rule of logarithms, that drops down in front. So what I'm going to get here now is negative 2y plus 5 in front of the logarithm log 7 of 7, log base 7 of 7. Now the special thing about logarithms, and this is why I liked that base of 7, is when the base matches the argument, crosses out, and you just get 1. Now times 1 means we don't need to write it. So here's my new simplified equation. It's log base 7 of x plus 1 equals negative 2y plus 5. Well, that's quite nice. Now I just need to get y by itself. Remember, I'm still solving for y here. So I'm going to subtract 5, like so. And now I have negative 2y. And now all I need to do is divide by negative 2. So whoopsie-doo, like that. And crosses out on this side. And that is y. Okay, now the fourth step, which again is not super important, is just to remember that this y equals the inverse. So we're done. That's the answer. That's what you would write into this box up here. Okay, and that is essentially how you find an inverse. This process right here in the blue box would work for any equation. It's just sometimes the equations, the solving part, gets a little more tricky like it was here.